Welcome everyone. This video here I'm going to explain a few things to help you out with a few other shapes. I think we're doing some work with some parallelograms. Now I have trouble saying that word, but I've brought something else in here. You can see on the camera here, this is a square. Okay, what we have to understand is this idea of perpendicular height. So this square is at right angles, 90 degrees, we might say. And I know in the corner there, that's going to be exactly 90 degrees. And that helps me with a lot of things. And that helps me rule a straight line on a bit of timber or a bit of steel. And so when I follow that line, I know that I'll get a nice square cut. And I can use this to check that things are at right angles to each other, okay? And that's important because what we've got here, and I'll hold the card up because there's a few other things we need to learn here. We need to look at the shapes now, and I've replaced those ticks with arrows. And those arrows, when you see them, they mean that those lines are parallel to each other. Okay, so they never get closer together or further apart. My bad drawing, but this serves two purposes. Tells me that they're parallel lines, and it also tells me that the lengths of these lines forming this shape are the same. So these two lines are also parallel to each other, and they're also the same length here. So where this idea of perpendicular comes into play is that we want to know, and I'll just turn the card here, and I could actually use my square here and make sure that I do a good job of this and set this up, and I'll turn to see if we can do this. What I need to know is the distance between a set of parallel lines here. So I've marked it in, I've used my square, and let's have a look. Did I do a good enough job there? So now this is a perpendicular distance between those two sets of lines. That's the measurement I need to use to correctly work out the area that this shape occupies. So that's really important. So I've just taken the time to show you that. And hopefully through these lessons, and I'll keep repeating it, that we need to be really careful about which measurement that we use to do our next set of calculations. Okay, I'll get behind the light board and show you some more, all right? In this video we've been talking about area of a parallelogram, and I made, in the introduction, I made a real effort to show you and talk to you about perpendicular height. So what we need to get used to is drawing as best we can two sets of parallel lines, and they might cross and intersect like this. Okay, and we might need to tidy those up a little bit and create our shape. So I'll do that, I'll scrub those little bits off, and we've got a shape that we could have a pretty good parallelogram here. We've got two sets of parallel lines, and those ticks, those marks, those arrows represent that those are two pairs of parallel lines. Now sometimes you might see little marks here to indicate that the opposite lines are the same length. Sometimes not, but normally we assume they are, right? So we need to talk about perpendicular height. So I'm going to write that word out here. Perpendicular height. And what I'm going to use is a little symbol. That means at right angles. Okay, so I'm just going to change the color of my pen in here, and somewhere in here I'm going to draw a dotted line inside the shape and put a little right angle there. Now, that line could be outside the shape, just as an imaginary line with a dotted line there. But that's the height we need. And it's really important that you don't get confused, because sometimes they'll put numbers on this line here. They might put a 5 on there. And you don't want to be using that number in your calculations. So we've got to remember that the area, I'm just going to use A now for area, and that is going to be the base times the height. And I'm going to shorten those two words and just write BH. And we all understand that's implied multiplication between those two letters. So that's what we're going to do here. And maybe we should do a few examples with some numbers just to get us started. But I want to come back and talk about something that helps us understand where this formula comes from. But we'll just warm up with a few diagrams, and we'll get used to doing these diagrams here. You can see my sketches are pretty rough and ready, and I'm going to call this 6 meters, and I've got a perpendicular height in here of 4 meters. So applying the formula, I get area equals base height, and I've got 6 times 4 here. So my area is equal to 24 meters squared. And they're the kinds of calculations that will get you to do. So we might have another one here where I guess what I'm going to set up this time is just showing you when the line is outside of the shape, and this one might be 3 meters. This is a perpendicular height, and let's just keep this at 6 meters. Our calculations are the same, base times height, and we've got 6 times 3, and that is equal to 18 meters squared as our area. So that's the kind of work that we need to do. So I'm just going to clean the board and come back and show you 2 more things. Now I'm just drawing my shape again, and really quickly, really roughly, I'm hoping that someone has shown you this, or we can quickly do it in class. Doesn't really matter. If we've got a perpendicular line down here, I'm imagining cutting off this shape, and if I bring it over here and put it on here, I've just created myself a rectangle. And it might be worth, just to help you see that, if I rub out that line and put it here. So I have got for all intensive purposes here, I've got a rectangle, okay, whose height here is equal to the perpendicular height, okay? So there's an interesting question that helps us tease this out, and I think it's worth doing, because let me quickly draw what we need. And here it is. I've got, let's say, a base of 10 meters, and I have got a length here of 5 meters, and I'm going to compare that to a similar sort of shape. But see, I'm putting my right angles in here just to make sure that you understand that this is a rectangle. And let's do the work here. We know that the area of a rectangle is equal to length times width, and we've got 10 times 5 which is 50 meters squared. And we're comparing it to this shape, and then this is where we need to watch out, because we've got a different formula, and the rookie mistake would be to come in here and just go 10 times 5 is 50. But this parallelogram over here, its area is smaller than this guy here, and let's prove that to you, because nothing's given in this shape about its perpendicular height. So in blue here, I'm thinking about a triangle here, and I'm thinking about if this length here is 5 meters, what I'm actually thinking about is using a bit of Pythagoras here, and that could be 4 meters and that could be 3 meters. Now I don't know which one it is. But let's work through both 3 and 4 as our perpendicular height, and that doesn't change the dimension of the length of that parallel line, but it'll let us see what's happening here, and hopefully through watching this you'll learn to avoid a common mistake. So let's say that this height is 4 meters. Okay, the perpendicular height of this parallelogram is 4 meters. So our answer would be 40 meters squared. Now let's change it. I'm just rubbing this out, and let's call it 3 meters, because I'm not sure what it actually is. It could be either of those options, and we end up at 30 meters squared. In both cases, the area of the parallelogram is less than the area of the rectangle with the same sort of dimensions labeled there. So we've got to be really careful, and we have to understand this idea of perpendicular height. Okay, thank you.